So in our very last section here, tying into section 4, geometric series can either be converging or diverging. I didn't make that little word but in our last video, but I didn't explain it because I wanted to explain it now. So the classification of determining whether something is converging or diverging is determined with the ratio. If the absolute value of our ratio is in between 0 and 1, basically meaning it's a decimal or a fraction in between 0 and 1, it's converging. If the ratio is bigger than 1, so the absolute, more specifically, the absolute value is greater than 1, then it's diverging. So are these series converging or diverging? Well, in order to find that out, remember that our ratio is determined by taking our second term and dividing the first term. So in this case, second term or third term divided by second term, fourth divided by third, whatever it is. So our ratio here would be a negative 1/3 divided by 1. Well, negative 1/3 divided by 1 is just negative 1/3. But we're not worried about the negative because we want the absolute value, which is just a positive 1/3. So we're good. This would therefore be classified as converging, because that ratio, 1/3, 0.333333, going on forever, is in between 0 and 1. Whereas if we look at this one, our ratio of negative 4 divided by 2, it being negative 2, the absolute value of negative 2 is 2. Well, that is definitely not converging. That is classified as diverging. And we'll talk about what these really mean. So the formula we have can only be used for a converging series. So you'll see S infinity. So the sum of an infinite series. And I'll come back to explain that in just a second. Our T1 is still our first term and our R is ratio. Now to explain the converging and the infinite series. The long story short is converging means when you add these numbers up, they will come to one specific value. Because if you have even 1 subtract a third, add a ninth, subtract 1/27th, add 1/81st, subtract 1/243rd, add 1/729th, so on and so forth, it's going to get closer and closer to one value. So as you have, let's talk about a number line. 1, let's see, that's 0. We can call that 1. Negative 1/3, so we're going to take 1. We're going to add it to negative 1/3. And then add that to, actually, it's going to make it a little smaller, 1/9. And then smaller. It's just going to keep on bouncing back and forth, closer and closer and closer to 0. Now we're going to find out that sum in just a second. But if we look at a number line on this, this is 0. If 2 is there, negative 4 is here. So 2 to negative 4. And then to positive 8. And then it'd be going to negative 16. And then it'd be going to positive 32. And then it'd be going to negative 64. Well, that's not even to the right scale. And then it's going to keep on going bigger and bigger and bigger. This is making it diverging. It's going further and further away from any kind of specific value. Whereas on our converging, it's literally converging towards one value. So we are going to actually determine the sum of the converging series above. So the sum of an infinite amount of terms. So as these terms keep on adding, It's just our first term. In this case is 1 divided by 1 subtract r. Sorry, I didn't know where my formula was. And in this case, our r value is -1/3. So 1 divided by 1 subtracting -1/3. So get a common denominator. That'd be 3 subtracting -1, which is 4/3. 1 divided by 4/3 is the same as 1 multiplying by 3/4. Well, 1 multiplied by 3/4 is 3/4. And that's all there is to it. Yes, there's more fractions, but that's finding the sum of a converging series. All right, have some fun.